Hello and welcome to the Daily Space for today, Tuesday, June 2nd, 2020. I'm your host, Dr. Pamela Gay, and I am here to try and put science in your brain. Today is a day of cognitive dissonance for many of us. Currently, the American Astronomical Society is meeting virtually with myriad astronomers from around the world coming together to celebrate our newest discoveries, our incremental advances in understanding, and to find tomorrow's collaborators. This is a celebration of science. At the same time, people are going to sleep to the sounds of gunfire here in the United States. I don't know what is happening in the coming days, but I'm proud of our peaceful protesters who are saying it is time for us to recognize that police must stop murdering people and that we must recognize that Black lives matter. Before I get to the science results, I need to say that science is worse off for the racism and biases limiting the options for so many people. We are an international program here at CosmoQuest, and we know people in our community have experienced hate for a myriad of reasons. In this moment, it is important for us to say Black lives matter. 1 in 1,000 Black boys and men will be killed by police in the U.S. No life should be thrown away. When humans with the potential to be the next Albert Einstein or Chris Hadfield are being struck dead walking home with Twizzlers and sometimes just die dancing or playing in the park, I have no words to express my sorrow. Our support does not say these lives matter more than others, but rather we recognize that culturally, in different ways in different places, some populations are treated as though they matter less. This is wrong. We are proud of the people within CosmoQuest who are peacefully participating in the Black Lives Matter movement in pride, and those who are opening their homes and communities to people escaping potential death in their native lands. We see your compassion and we commend it. The science we bring you today comes from people all over the world, and we start with a story from Monash University in Australia. Graduate student Adele Goodwin has made the first ever start-to-finish observations of a cataclysmic variable star. This system consists of a neutron star, a regular companion star, and a whole lot of gravity that is tearing material off the companion star and pulling it into a disk around the neutron star. As this disk grows, it will dump material onto the surface of the neutron star. This isn't a continuous process, but occurs in spurts. For decades, folks have tried to catch these systems at the moment an outburst begins, and campaigns involving amateur astronomers monitoring these variables have been common. Despite all these efforts, no one had been able to acquire detailed observations across multiple wavelengths. At least not until now. In a new paper in the monthly notices of the Royal Astronomical Society, this team describes the behavior of a system captured at the moment of the outburst. Over the course of 12 days, they performed high-sensitivity optical and X-ray observations as material swirled inward to collide with the neutron star surface. This 12-day duration was the first of their discoveries. It had previously been thought that outbursts consistently lasted just 2 to 3 days. According to Goodwin, using multiple telescopes that are sensitive to light in different energies, we were able to trace that the initial activity happened near the companion star, in the outer edge of the accretion disk, and it took 12 days for the disk to be brought into the hot state and for material to spiral inward to the neutron star and X-rays to be produced. This science, it required 5 ground and 2 space-based telescopes. This kind of continuous coverage over many different wavelengths of light is amazing. This system is 11,000 light years away, and the neutron star is a special kind of neutron star, a pulsar that rotates 400 times a second. This theory-defying slow burn and burst pointed towards something being out of spec with this system. Thanks to the tremendous data set they acquired, it was possible to measure the composition of the material in the disk, and they discovered it had a much higher helium content than has been observed in other systems. While most accretion disks are primarily hydrogen, this disk was measured to be 50% helium, a gas that burns at a hotter temperature. Just as it can take longer to preheat your oven to higher temperatures, it takes longer to preheat a disk to detonation temperatures when it has to go to a higher temperature. This 12-day duration reflects the higher temperature needed to trigger the helium. While this paper largely focuses on the observations, we expect more to come as Adele finishes her PhD and as, we hope, more systems receive this kind of intensive observation. Now, from global observations of one system, we now turned to Arizona observations of one object. For those observing gamma rays, there is a new telescope array in town. The prototype Schwarzschild Coder telescope is testing a new design for detecting the cascades of light created when high-energy gamma rays strike our atmosphere. Called Cherenkov radiation, these cascades can be seen streaming away from their origin point on the sky. Until now, the systems used to detect these cascades were consistent. The systems used to detect these cascades consisted of massive multi-segment detectors and a prime focus camera that hung awkwardly above the dish. This new system, for the first time, uses a secondary mirror to reflect the light through the segmented reflector and to instruments below. This allows bigger detectors to be used and grants easier access to the system, allowing easier innovation. To prove their system worked, the Cherenkov Telescope Array team pointed their scope at the Crab Nebula, one of the nearest sources of massively high-energy particles. And they were not disappointed. Their prototype system is working nicely, and now they can move on to work on a larger system. What we see in this animation here is a white square blocking out the point on the sky where the Crab Nebula is located. The colored streaks we see are particles emanating from the Crab Nebula and streaming through our atmosphere. When the system is complete, they will be able to detect via Cherenkov radiation sources of the highest energy light in our universe with greater sensitivity than has ever been possible. And we can't wait to see what they find. Our final story of the day carries us to the European Union and looks towards the sun and, well, other stars. Most of us are familiar with sunspots, dark, cool blemishes on the surface of the sun that appear and disappear. Now, astronomers using the European Southern Observatory telescopes have announced that they have found stellar spots that are hotter and brighter than the surface of their stars. The stars, in this case, are extreme horizontal branch stars. They're half the mass of our sun, but 4 to 5 times hotter. Usually, we observe these types of stars in our own galaxy with a companion star. They can also be found in globular clusters and generally don't seem to have companions. They do, however, change in brightness, and that is what attracted the attention of astronomers who conducted long-term observations of these stars. The changes in brightness lasted days to weeks, and scientists like Simone Zaga of the INAF Astronomical Observatory of Padua concluded these stars must be plagued by spots. The spots on these extreme horizontal branch stars are much bigger than sunspots. They can take up a quarter of the surface of the star, which is why the star's brightness changes as it rotates. Additionally, these stars showed signs of superflares, stellar flares similar to those we observe on the sun, but with 10 million times the energy. Flares such as these are compelling evidence for magnetic fields in these smaller, hotter stars. The big picture here is, as former ESO fellow Dave Jones said, changes in brightness of all hot stars could be connected. And this research may help us explain the existence of magnetic fields in other stars like white dwarfs. This is the start to understanding one of the most complicated topics in astrophysics, magnetic fields in stellar atmospheres. And we're glad someone other than us is making sense of these twisting fields. And that rounds out our news for today. We are currently waiting to get papers and press releases from news that came out earlier today at the American Astronomical Society meeting, and there will be additional press conferences and additional new science coming out of the AAS later this afternoon, as well as 2 more press conferences tomorrow. What this means is Thursday, the news will be rich. Well, today is seemingly a little bit lean compared to, well, yesterday. Tomorrow will be our regular rocket roundup, and oh, what a roundup it will be. For now, though, this is all we've got. This has been The Daily Space. Thank you all for being here. Today's script was written by both me and Beth Johnson. Our audio and video will be engineered by Ali Pelfrey, and our web content will be produced by Beth Johnson. All of us are supported by a myriad of volunteers who could be you. Thank you if it is you. And we are supported through the generous contributions of your bits, your subs, and your patronage at patreon.com/CosmoQuestX. So many thanks to all of you who make everything we do possible. I'm now going to hang out and answer your questions as best I can. All right, let's see what we have. Thank you for gifting the sub to Larry Weird, Adam Altogether. You could not have chosen a better person to gift a sub to. There is a lot going on in which picture, Hanny? Where could the extra helium come from? Okay, so you're looking at the accretion disk. It implies that the star that they're stealing material off of has a helium-rich atmosphere. I can't explain that one. Honestly, we need more research on this object. This is weird, and weird things are cool, and we want more information, please. Let's see what else we've got in here. Bill Nash, if you're still out there, you kind of rock. Thank you so much for the bits you dropped right after we went off air in the last hour. Hello, Broken Symmetry. Welcome, Badlands Bear, or are you referring to Bad Panda Bear? Scrolling. So Hexacosacoron says, I wonder how the tidal forces affect the matter circulation in a star. This is one of the things that we're working on trying to figure out. There are planets snuggled up very close to the stars they orbit. And as you end up with larger planets orbiting bigger stars, they do actually raise up surface waves on the star they pass over. So what we see is the planet is tidally locked to its star. Its atmosphere is devastated. But that planet in turn is able to yank up on the surface of the star, really creating a crazy awesome system that we don't know how to understand fully yet. So Larry Weird, you definitely had one of those Hollywood awards shows moments. So do we have any other questions out there? I will be back at 3 p.m. Eastern. That is an hour and 45 minutes from now to bring you the next press conference from the American Astronomical Society meeting. Michael is not here. He is making his dinner. Oh, Jillian, yes, these things happen, but you can always catch the VOD. You can always catch the VOD. If there are no additional questions, I'm going to go ahead and record our podcast, find some lunch, and then if nothing else explodes, nothing has actually exploded except for my inbox, but that can be rather dramatic. I'm going to go ahead and finally get our community coffee set up on our YouTube channel. So there is so much going on, and it's kind of awesome. I am not seeing any more questions coming in, so let's Let's see what all we've got. Is there anything else anywhere? So many windows. So many windows. Oh Bother is streaming. So we are going to raid Oh Bother. And I am going to go find I'm going to go find lunch. I like Larry's comment that SN5 is not due to blow up today yet. I too am going to have leftovers. Mine are dirty rice. All right. So this has been the Daily Space. I was your host, Dr. Pamela Gay, and Beth Johnson and I wrote today's episode. This episode will be engineered by Ali Pelfrey, and our web content will be produced by Beth Pelfrey. We are a product. We are part of CosmoQuest. Learn more about everything we do at cosmoquest.org. We are a product of the Planetary Science Institute, a 501c3 dedicated to exploring our solar system and beyond. We are here thanks to you, your volunteer efforts, your bits, your subs, your donations at patreon.com/CosmoQuestX. All that put together, well, you are what allow us to do everything that we do. So thank you. And wherever you are in the world, stay safe. It's a changing time. But together we can get through this. So be well, my humans. And if you go out, wear a mask. If you stay in, see what you can do to take care of yourself and maybe take care of someone else along the way. We're going to get through this together. I no longer know what to say to end this episode. I'm going to work on that as well today. I'll see you all on the other side.